Today we're going to be recording the chapter 5 CQDs. They're really easy this time because they're material we already took last year. So now let's start solving. So, wait, just me see something? Okay. So, first question is asking us, when you have 4 moles of Fe reacting with excess chlorine gas, what mass of FeCl3 will be produced? We already took this last year. You have to use RR and GR. So I wrote down our equation. You have Fe reacting with chlorine gas, producing FeCl3, and I balanced it. So now, let's solve. So you have, this is our reacting ratio, and this is the given ratio. You have 4 moles of Fe. So 4 mole of Fe reacting with excess chlorine gas. So we don't even look at chlorine because it's in excess and we only work with limiting reagents. What mass of FeCl3 will be produced? So you need to know what mass. So in grams, how much of it will be produced. So we know here we have 2 moles of Fe. So here we have 2 moles. This is in our reacting ratio. And here we have, to find how many grams is in our reacting ratio, we do 2 times the molar mass of FeCl3, which if I use my calculator will find to be, so 56 plus 3 times 35.5, and it's gonna be, so 2 times 162.5, which is the same as 325. And now you cross multiply. So you do 4 moles times 325, divide by 2. So times 4, divide by 2, and you're gonna get that you have, wait, let me see because I have the answers in my copybook. I got that we have 650 grams of FeCl3, so 650 grams. Now here they're asking us what volume of chlorine at STP. STP is 22.4 decimeter cubed, reacts with 4 moles of Fe. So again, we have the same reacting ratio for Fe, but we have a different, we're working with the other one, we're working with chlorine. So you want to know what's the volume, so how much in decimeter cubed is reacting with 4 moles of Fe. So our reacting ratio is 3 times your molar volume, which here it's at STP, so 22.4. So 4 times 3 times 22.4 is, and then you have to divide it, so you multiply this by this, then you divide it by 2. And when you divide it by 2, you're gonna get 134.4 decimeter cubed. And since all of our numbers were given to 3 significant figures, if we're gonna make it in 3 significant figures, it's around 134 decimeters cubed. And that's how you solve for the first question. Now we have CQD 3. So for CQD 3, it's telling us you have hydrogen gas, H2, reacting with carbon monoxide gas, CO, to produce methanol, as shown in the following reaction. So here they gave us a reaction. So the question states, when 0.50 tons of H2 gas react completely, we take that as a keyword, with CO gas, the amount of methanol produced was 3 tons. Calculate the percentage yield. So for percentage yield, we need to memorize a equation. So the equation is, I'm gonna write it over here, percentage yield equals actual yield, so actual yield over theoretical yield times 100. Your theoretical yield is the yield you get when you do RR and GR with the limiting reagent. So anyways, here we don't need to see which one's the limiting reagent because they told us H2 reacts completely, making it the limiting reagent. So we need to first find out what's our theoretical yield, which we find that because the actual yield is usually given. The amount of methanol produced, the actual thing that was produced is 3 tons. If you notice here, all our measurements are in tons. Tons is 1,000. 1 ton is 1,000 kilograms. So let's rewrite our equation up here so we can do our RGR to find our theoretical yield. So 2H2 plus CO produces CH3OH. So we know we have 0.50 tons of hydrogen. This is our given ratio. So reacting ratio, given ratio. We were given the mass of hydrogen used, which was 0.50 tons, which means 0.5 times 10 power 6, negative 6, or well, no, actually it was 6 because you're making it grams. So 0.5 times 10 power 6 grams. And your reacting ratio was 2 into the mass of H2. H has a molar mass of 1. H2 has a molar mass of 2, so you have 2 moles of H2, so it's 2 into 2. And you need to know how much methanol was produced. The amount of methanol was produced, and you need to find the percentage yield. So now, don't go putting that the amount produced was 3 tons. This is how much was actually produced. You want to know how much theoretically it should produce. So what you do is you put down the molar mass, the reacting ratio of CH3OH, which we find to be, so let me calculate it really quick. It should be 32. So 12 plus 3 plus 4 actually plus 16. Okay, yeah. So this is 32 grams. I'm gonna replace this here with 4 grams because it's easier to work with. That's not a 9, that's grams. So 0.5, you need to do 0.5 times 10 power 6 times 32. Then you divide that by 4. You're gonna get 4 times 10 power 6. So now we know our theoretical yield. So here in the box we get, here's the question mark, and the question mark is equal to 4 times 10 power 6. So now we need to use our equation. Our actual yield, which was the one given to us, is 3 tons. So 3 times 10 power 6, because you need everything to be in grams or tons, but I'd rather have it in grams, over the thing you found, which is 4 times 10 power 6, times 100 will give you our percentage yield. So let's calculate it. 3 times 10 power 6 over, I'm doing all these on my calculator, by the way, if you don't see me doing it on screen, times 100 will give us our answer, which is 75% yield. All you have to do is you memorize this equation. You need to see your actual yield is usually given. You need to calculate your percentage yield with the limiting reagent, unless they give you the limiting reagent. If they don't, you have to find the limiting reagent by doing what we learned last year. Now we have CQD 17. Now CQD 17 tells us that we have a metal zinc reacts with acid to release hydrogen gas, H2. What volume of hydrogen gas would be produced at room temperature and pressure, so RTP, when 3.27 grams of zinc react completely with excess sulfuric acid. Here they gave us which one's limiting and which one's excess, so we just have to solve. Now, let's see. You have the metal zinc. So in our equation we have zinc reacts with an acid. I'd use and releases hydrogen gas. And you have excess sulfuric acid. So they told us that our acid used was sulfuric acid. So H2SO4. To produce hydrogen gas, so to produce H2, and of course ZnSO4, because when you need to do the reaction, it's a metal with a acid forms hydrogen gas and a salt, so the salt will be ZnSO4. It's already balanced, so we don't need to balance. So what volume of hydrogen gas would be produced? So you need to know how many decimeter cubed would be produced at RTP. So we need to multiply the coefficient here by RTP, which is 24, but the coefficient is 1, so we don't multiply by anything. When 3.27 grams of Zn, so GR. So 3.27 grams is our given ratio of Zn was used with excess sulfuric acid, and they told us Zn has a molar mass of 65, so here it's 65. They want to know how many decimeters cubed. So again, just cross multiply 3.27 times 24 divided by 65. Let me calculate it quickly on my calculator. And you're gonna get something around, like when we're gonna round it to 3 significant figures, you're gonna get 1.21 decimeters cubed. It's actually 1.20738, but we're gonna round it to 3 significant figures because all our given is in 3 significant figures. By the way, when looking at the givens, you always take the givens like this. You don't take fixed values like these two as your significant figures. Now, CQD 20 tells us, okay, actually guys, I just checked, and these questions, CQD 20 and CQD 19 and exercise 10 are all materials that are after what's required with us. It's not 5.2, so it's not included with us in the exam. So that's all the CQDs that are included with us for the exam. But on the paper, for the course question documents, it says that we have an extra 2 questions that aren't on this paper. So I'm gonna go quickly and solve them. Let me open the CQD for the CQD paper. Okay, so I opened it. We have question 21 and 22 with us, as it says on the paper. So during a lab session, students were asked to prepare hydrated magnesium sulfate by adding excess of the dilute sulfuric acid to the magnesium oxide. Each student was handed a different mass of magnesium oxide, and MgO with excess H2SO4 turns into MgSO4 with SH2O, which is hydrated magnesium oxide. Magnesium sulfate, I mean. At the end of the experiment, each student dried and weighed the crystals they obtained. Which student produced the highest percentage yield of hydrated magnesium? We said percentage yield is actual yield over theoretical yield times 100. That's how you find the percentage. So here, what we need to do is we need to use the mass of the crystals produced over the ones you used and find the one with the highest ratio. So first one, you do 9.5 divided by 5. So 9.5 divided by 5 will give you 1.9. Here you don't really need to multiply by 100 because you're using the ratios. Now here 24 divided by 10 is 2.4. 35.8 divided by 16. You're gonna get 2.2375. 46.6 divided by 24 is gonna give you 1.9416. I'm gonna stop there because it keeps repeating. And then for E, you do 56.7 divided by 36, and you're gonna get 1.575. And as you can see, B here is the answer because it has the highest ratio, which means the student that had B produced the highest percentage of hydrated magnesium sulfate. Now we need to read question 22. So the question says ammonium sulfate, NH4 is used as a fertilizer. It's produced from ammonia and sulfuric acid as shown in the chemical equation. Calculate the maximum mass of ammonium sulfate produced from 680 grams of ammonia using the following steps. And the formula mass of ammonia, which means the molar mass in other words, is 17 grams. So first thing they want us is to calculate the moles of NH3 in 680 grams. We know that the rule for moles is moles equals mass over molar mass, or relative formula mass, as they call it here. So they want the moles of NH3. So in 680 grams. So our mass given is 680 over our molar mass, which is 17, which you should get, let me calculate it really quickly, 40. So you have 40 moles used in the 680 grams. So how much moles of NH4 to SO4 is used here? What you need to do is RGR. So you take this, I'm going to write it over here, 2NH3 plus H2SO4 gives NH4 2SO4. RGR. So the number of moles of NH4 2SO4, you find it by doing, you know there's 2 moles in the reacting ratio, and we just found that there's 40 moles in the given ratio. We calculated it. They want how many moles of this are formed. So how many moles? As we can see here, you only have 1 mole of this. So what you do is 40 times 1 divide by 2. So 40 times 1 divided by 2 should give you 20. Now here they want you to calculate the molar mass of NH4 to SO4. For this you need a what's it called? You need a periodic table. I have one in front of me, so let's see. N is 14 plus H4. One H is 1 mole, or not 1 gram, and you have 4 of it, so plus 4, and all of this multiplied by 2, because that's a subscript. And then plus S is 32 plus 4 times O. 1 O is 16. So 2 times 8. So when you put all of this in your calculator, it's 36 plus 32 plus 4 times 16. You should get all equals to 132 grams. Now we need to use this mass to calculate the maximum mass of ammonium sulfate produced. So now we delete the moles because we're not using the moles anymore. We're using the mass we found. How many grams? Using 132 grams. So 40 times 132 gives us 5,280 divided by 2. Should give us 2,640. Let me check if it's correct. 2,640. Yes. So 2,640 grams. And that's all the questions included with us from chapter 5 for the periodic. Hope you understood everything. Have a good day.